Day 3, AP Physics, homework problems from page 85, problem number 10. Here we have a graph of a car that's limited to two different directions. I like to call it the positive direction and negative direction. They can call it forward and backward, same difference, or you could say north and south, where north would be the positive and south would be the negative. So you have two directions that it can only go. It's not going to be turning. And what's happening in this particular problem is the car, when the problem starts, is going 20 meters per second in the negative direction. We don't know where the car is at, but we do know that the car, this is time zero, this is the time axis, but at time zero and for the first half a second, because that represents a half a second time, that's 1 second right there. So for half a second, it's going in the negative direction, possibly backing up. If the car's not pointing in that direction, but it could be pointing in that direction and going in that arbitrary negative direction. Well, then what happens is it's backing up or going in the negative direction at that speed for half a second. Then it's either taking the foot off the accelerator or putting the foot on the brake and steadily, uniformly decelerating to a stop. And it takes a second for it to stop. So now we're at 1.5 seconds. Then it stops for half a second. It's stopped for half a second. Then it starts going in the other direction, the positive direction, and speeding up. And the slope of this line would be the acceleration. It's a greater positive acceleration than it was the negative acceleration. The slowing down speed right here would be the slope, or the acceleration, I should say. The slowing down acceleration would be a little bit less severe than the speeding up acceleration here. Car speeds up for half a second, from 2 to 2.5 seconds, and then it maintains a particular speed for 1 second, hits the brakes and steadily slows down. So it's a negative acceleration, negative slope at the same, looks like the same rate as the positive acceleration from 2 to 2.5 seconds. So once again, this graph does not tell us where the car is at any particular point in time. However, if you found the areas under these shapes, like this area here, like this trapezoidal shape, that would tell you the amount of displacement it covered in that particular time frame. And this would be the, actually, I should say that the change in the displacement in that time frame. And this would be the displacement in that time frame. You figure out all that area. But we're not going to be doing that right now. We need to figure out the average acceleration over given time periods. And once again, the definition of average acceleration is A average equals the change in the velocity over that time divided by that particular time, or the change in time, the time elapsed. Now, we do a lot of problems where the acceleration is uniform. There are 4 uniform acceleration questions. We're not going to apply those, or equations. We are not going to apply them here, but we can look in this particular situation. There are a bunch of uniform accelerations from 0 to 0.5 seconds is the first frame, from 0 to 5 seconds, from 0 to 0.5 seconds, the acceleration, and I'll just make a graph over here, the acceleration we can say is 0 meters per second squared, and we have standard units here, meters per second and seconds, because the graph is flat from 0 to 0.5 seconds. Then from 0.5 to 1.5, 0 seconds to 1.5 seconds, we're just going to find the slope of that line. And we're going to do it by observation. The slope of the line, or we could use that equation up to the change in velocity over time, which basically does give you the slope of that line. It's just the rise over the run. The change in the velocity, in other words, is the rise. It goes from negative 20 to 0. So it's an increase of 20 meters per second in a time of 1 second. So the acceleration in that case is 20 meters per second squared. I've just basically plugged in that equation up there in my head because it's an increase or a change in velocity of positive 20. So it's a positive acceleration. From 1.5 to 2 seconds, there's no acceleration once again. So you can kind of see the idea here. That's 1.5 to 2 seconds. It's 0 meters per second squared. And then from 2 to 2.5 seconds, it's an increase of 40 meters per second in 0.5 seconds. So the delta V, the rise, is going to be 40, and the time is going to be 0.5 seconds. So 40 divided by 0.5 is 80 meters per second squared. That's quite an acceleration from 2.0 to 2.5 seconds. That's 80 meters per second squared. That's basically almost impossible for a car, because that's like 8 times what gravity does. But that'd be positive. And then 0 acceleration for that 2.5 to 3.5, and then the negative 80 meters per second squared from 3.5 to 4 seconds.